Hi guys, welcome to my channel, and this is the fourth video regarding electrochemistry series, and topic is reference electrodes. In this, standard hydrogen electrode and Calomel electrode both will be discussed, and mainly focused on what is reference electrode. So what is the significance of reference electrode, how they construct and work. These things will be discussed in this topic. I'm strongly recommending you to watch previous videos regarding electrochemistry. Why? Because every topic is interlinked. So single electrode potential. So electrode potential corresponding to single electrode is called single electrode potential. So electrochemical cell is a device which produces electricity by performing a redox reaction. A redox reaction means oxidation and reduction takes place, but not at a place. To separate the oxidation reaction and reduction reaction, we need two OP cells, each OP cells containing one electrode and its electrolytic solution. So that's why there is a two electrodes is there, each electrode having some specific potential value. That potential value is called single electrode potential. But electrochemical cell produces electricity. The capacity of the cell is mentioned as EMF of the cell. EMF of the cell is because of both oxidation potential of anode and reduction potential of cathode. It is a combination work of both anode and cathode. That's why if the oxidation potential value of anode is X and reduction potential of cathode is Y, then X plus Y is equal to EMF of the cell. Okay, so but you are unable to determine the X value exactly unless until you know the Y value. The same vice versa. So here you can't find X value until unless fix Y value and vice versa. So it is impossible to know the absolute value of a single electrode potential. If you can fix arbitrarily potential value of any one electrode, then we can measure the other electrode potential by using potentiometer. For this purpose, reference electrodes are introduced. So reference electrodes are used to determine the single electrode potentials value of different metals. So we have a copper metal, we have a iron metal, we have a zinc metal, but we are unable to determine the exact value of their potential values. So by using these reference electrodes, we can determine the all metals electrode potential values. So what are the characteristics of reference electrode? First thing is reference electrode potential should be known. Okay, so whose potentials are extremely known, that is called reference electrode. So it is used for construction of electrochemical cell by taking it as a one of the op cell. So electrochemical cell having two op cells, we will take this reference electrode as one of the op cell. Okay, by which we can determine the unknown single electrode potential. Remaining option is unknown electrode. We will connect this reference electrode and unknown electrode through a external wire. Then it will give the potential value. It will give the EMF of the cell. So by that we can determine the unknown electrode potential. So there is a two types of reference electrodes is there. So primary reference electrode and secondary reference electrode. These two will be discussed in this topic. Let's start with standard hydrogen electrode SHE. So it is also called normal hydrogen electrode NHE. SHE is the example for primary reference electrode, and its electrode potential value is arbitrarily fixed as 0 at all the temperature. So SHE electrode potential value is 0. That means one of the op cell, we will take it as a one of the op cell in electrochemical cell. Okay, so one of the op cell electrode potential we already known, it is equal to 0. So this electrode may serve as anode or cathode depending upon the nature of the other electrode to which connected. So this is the one of the op cell. SHE is one of the op cell. So another op cell we will take unknown metal. That metal may be anode or cathode. So if it is anode, it is ready to act as cathode. So connected metal is cathode. It is also ready to act as anode. So that's why this reference electrode, standard hydrogen electrode, may serve as anode or cathode depending upon the nature of other electrode. I will explain this later slides. If you see the construction of standard hydrogen electrode, there is a platinum wire. There is a platinum wire is there. So that wire in the bottom side, a platinum plate is taken as a electrode. So here, for example, if you observe the galvanic cell, there is a two options is there. Zinc metal dipped into zinc sulfide solution. Copper metal dipped into copper sulfide solution. One option is called zinc. In the one option, zinc electrode is there. Another option, copper electrode is there. So here, hydrogen electrode is there, but hydrogen is a gas. We will not make it as a solid. We will not make a hydrogen rod. For example, zinc rod is there, copper rod is there, but we will unable to construct a hydrogen rod. For that purpose, we will take a platinum wire with a platinum foil. So when you pass the hydrogen gas at 1 atmosphere pressure over the platinum rod, so when you pass the hydrogen gas at 1 atmosphere, this condition is very important. You need to pass hydrogen gas at all the time with 1 atmosphere pressure over the platinum wire. Then hydrogen gas is absorbed over the platinum wire. So here, if you take the platinum foil, hydrogen gas will be absorbed here. So that means it seems to be like a hydrogen rod. Actually, it is a platinum wire, platinum foil. But when our platinum surface is fully covered with a hydrogen gas, it seems to be like a hydrogen rod. So hydrogen rod we will make it. Then it will dip into its own ions. Its own ions means H plus ions. We can take any acid, HCl, H2SO4, H3PO4. We can take any acid with 1 molar concentration. So H plus ion concentration should be 1 molar. So when platinum wire absorbed by the hydrogen gas is dipped into 1 molar hydrogen ions, then it is called hydrogen electrode. It is used as a reference electrode to determine the unknown electrode potential. We can represent this electrode as like this. Here we take a platinum metal. On that platinum metal, hydrogen gas is absorbed. So it is at 1 atmosphere and it is dipped into 1 molar hydrogen solution, hydronium ions. Okay, this is representation. Platinum wire is there. On that platinum, hydrogen gas is there. So it is 1 atmosphere pressure we are passing and totally dipped into 1 molar hydronium ions. So this is a representation of standard hydrogen electrode. So here conditions are important. You should always aware of 1 bar pressure or 1 atmosphere hydrogen pressure and also 1 molar hydronium ion concentration at electrolyte. Those are the important. Let's see how standard hydrogen electrode act as anode and cathode. So for example, if it is acting as a anode mean it should involve in oxidation reaction. Oxidation reaction mean it should releases electrons. Okay. So we are passing hydrogen gas over the platinum wire and it hydrogen gas is adsorbed on the surface of platinum foil. If you look at here, so this is the this is the platinum foil. So if you see the close look, so on the surface, so we are passing hydrogen gas here. This hydrogen gas is absorbed here. So there is a oxidation takes place, H2 converting into H plus ions by releasing two electrons. It is releasing two electrons and it is converting as a H plus. So here two electrons are released. These released electrons transfer to here. If you see the electrochemical cell is it, this is SHE. This is SHE and it is a copper electrode is connected between. So it is act as a anode. SHE act as a anode. It releases electrons. That electrons move through the external wire, reaches to copper. Copper plus 2 ions involved in reduction. They consumes the electrons. This is nothing but redox reaction. It produces electricity. This produces electricity. So like that it can act as a anode. So for example, if it is act as a cathode mean it should involve in reduction. Reduction mean it should accept electrons. For example, if you connected with the zinc rod, so SHE is connected with the zinc rod, zinc electrode. Here zinc involved in oxidation process, and it is releases electrons. That electrons reaches to SHE. So now the released electrons, the accepted electrons is consumed by the H plus ions, and H plus ion now converting into H2 gas. Where this H plus ions, the SHE is a standard hydrogen electrode having a 1 molar H plus ions. These H plus ions are converting into a H2 gas. So like that, there is a two chemicals is there in the SHE. One is hydrogen gas, one is H plus ions. When it is acting as anode, H2 takes responsibility, H2 converting as H plus by releasing electrons. Anode mean oxidation, H2 releases electron, that electron reaches to the cathode. So when it is acting as a cathode, cathode mean reduction, reduction mean it accepts electrons. Here H plus ions takes that responsibility. H plus ions accept electron from the anode, H plus ions converting into H2. Okay. So these will be explained here. So for example, SHE act as anode. SHE is act as anode. That means oxidation should take place. Hydrogen gas present in the SHE releases two H plus ions and two electrons. The two electrons released from the SHE, here you can see SHE act as anode. These two electrons reaches to the cathode. Cathode accept the two electrons. Redox reaction completed. It produces potential value. Now x plus y is equal to 0.337, but we know the x value means standard hydrogen value 0 plus y is equal 0.337, then y is equal 0.337. Like that we can determine copper electrode potential, copper single electrode potential by using reference electrode. So if it is connected with the anodic material, that means SHE is connected with the anodic material, so SHE should act as cathode. So the cathode mean reduction should be takes place at the cathode. Now H plus ions present in the SHE take responsibility. So we are connecting with the anodic material. Anode method releases electron. So it accept SHE accept that electrons and converting into H2 gas. So because of this here oxidation takes place and SHE at reduction takes place. It is produces the EMF 0.76 is equal oxidation potential of anode X plus reduction potential of cathode Y. So that means X plus Y is equal 0.76, but we know the Y value is 0. So X plus 0 is equal 0.76. So X is equal 0.76. Like that we can determine the every single electrode potential by using standard hydrogen electrode. So like that we will make it a list. When you calculate the all metal electrode potential, when you make it list in a order of increasing order of reduction potential, it is called electrochemical cell. I will explain it later session, so that is very important. So here why zinc is acting as anode, why always copper act as cathode, so why copper act as anode, why should not copper act as anode, why should not zinc act as cathode? These all questions will be answered by using electrochemical series. Okay, so electrochemical series. So another example here, Calomel electrode. So what is the need of Calomel electrode? We have already standard hydrogen electrode. What is the need of Calomel electrode? If you see the standard hydrogen electrode, we always pass 1 bar atmospheric pressure of hydrogen gas, and we also always maintain the 1 molar hydronium ions. When it is act as anode, H2 gas is consuming. That means pressure will drops. So but we need to keep always pressure at constant at 1 bar pressure. So when SHE act as cathode, H plus ions are converting into H2. That means concentration alters. So but it should not happen. Always we need to maintain H plus ion concentration at 1 molar and H2 gas pressure at 1 bar. It is little bit difficult to maintain the process throughout the examination. That's why a simple and practically used Calomel electrode is determined is introduced for the better calculation. So Calomel electrode is an example for secondary reference electrode. It is also called mercury mercurous mercurous electrode. So that means it contains mercury Hg and also solid mercurous chloride. Mercurous chloride is Hg2Cl2. It is also called calomel. That's why the total electrode is called as calomel electrode. So it is also serve as anode or cathode depending upon the nature of the another electrode. Just like SHE, it can also able to act as anode when it is connected with cathode, and it is act as cathode when it is connected with anode. So it is ready to act as anode or cathode depending on the connecting method. What you are connecting. For example, if you connect a cathode, if you take a cathodic material, for example copper metal you take here, so copper and copper sulfide solution, when you connected this copper and copper sulfide, sorry, actually I have to draw here, so wait, so I need to draw here. So when you take a, so this is a salt beach, so copper metal. So when you connect it with copper metal to calomel electrode, so copper act as a cathode. That means it requires electron. So now calomel electron releases electrons. It act as a anode, anodic material. So it releases electron. Electrons move from anode to cathode. So what? How it is act as a cathode? Cathode mean it should involve in oxidation process. Okay. Before going that, you should see the construction of calomel electrode. It is a vertical tube with two side tubes, a vertical tube with the two side tubes. So it containing the platinum wire in the middle of the vertical tube, and the bottom of the tube with filled with the mercury. Mercury is a metal, but it is in a liquid state. So only metal available in liquid state is mercury. Just above the mercury, we will add a paste of mercurous chloride Hg2Cl2 paste. That means it is also a solid. So solid concentration is always equal to 1. We already know this one. All solid concentration equal to 1. All metals, pure metals concentration also take it as a 1. So Hg concentration is 1. Hg2Cl2 concentration is also 1. So and here by using this cap, we can fill this calomel electrode with a KCl solution. KCl electrolyte is filled over the mercury and mercurous chloride. This is the construction of calomel electrode. Okay, this is the construction of calomel electrode. So now how it is work as a, how it is acted as an anode. Anode mean it should involve in oxidation reaction. Oxidation reaction mean it should releases electron. If you see here, just H2 take response, Hg takes responsibility. That means mercury present in the calomel electrode takes responsibility during oxidation process. Now Hg converting into ionic form, Hg2 plus 2 electron, it releases 2 electron, but it is available, Cl minus ions is available. That's why immediately produced Hg2 plus interact with the Cl minus ions and produces Hg2Cl2. If you combine these two reactions, you will get final reaction 2Hg plus 2Cl minus gives Hg2Cl2 plus 2 electrons. So if you see the overall reaction here, Hg is going to converting into Hg2Cl2 and it is releasing electron. Releasing electron is called oxidation. So it releases electron. That electrons travel through the external wall. It reaches to the copper metal. So because of this transformation, EMF generated. So EMF will be measured. So X plus Y is equal to EMF. The calomel electrode potential we already know. So what is the reference electrode? Whose electrode potentials are already known. I didn't mention how much is the calomel electrode up to now, but we already known it. I will reveal the value at the later end of the session. So we already know the calomel electrode potential. That means X value we know. X plus Y is equal to EMF of the cell. So like that we can determine the copper electrode potential. So if it is act as a anode, that means calomel is act as a cathode. So that means it should accept electrons. That means you should connect this metal, you should connect this calomel electrode with a anodic metal like zinc metal. So zinc is dipped into zinc sulfide solution, zinc sulfide solution. So now zinc metal is connected with the calomel electrode. So zinc is a anodic metal, it involved in oxidation, it releases electrons. So now it should accept electron, it should accept electron. That means it should involve in reduction. Reduction mean reduction takes place at cathode. Now mercurous chloride takes responsibility. So whenever it is acting as anode, mercury is taking responsibility. Whenever it is acting as cathode, mercurous chloride, here mercurous chloride is there. This mercurous chloride first ionized into Hg2 2 plus 2Cl minus. Now the electrons from the anode, these electrons is consumed by the Hg2 2 plus and finally converting into 2Hg. If you write the overall reaction, Hg2Cl2, 2 electrons, it gives 2Hg plus 2Cl minus ions. So here consumption of electrons is there. This is nothing but reduction. Reduction happening means it is acting as a cathode. So whenever you connect with anode, it acting as a cathode. When you are connected with cathode, it act as a anode. So like that, if you consider this reaction, and apply the next equation, you can write the electrode potential value is equal to E naught minus 2.303 RT by NF into log Cl minus ions. So this is the products by reactants. So but reactant Hg2Cl2 is a solid, that's why we are not considering the concentration of Hg2Cl2. H2 is a metal concentration also 1, that's why there is no other products at the concentration term, only Cl minus ion is there. So finally, so these all are the constant values. R is a constant value at a constant temperature, T is also Faraday's constant, and number of electron transferred is 1, it is also constant 1. E naught value is also constant 1. Only E value varies with the concentration of Cl minus ions. E only depending on the concentration of Cl minus ions. So since the calomel electrode potential depends on the concentration of KCl solution. So how much KCl, how concentrated KCl solution is dipped into, filled into the calomel electrode is decide the electrode potential of the calomel electrode. If you fill the saturated KCl solution, the potential value is become 0.2422 electron volts. Most often used calomel electrode is a saturated calomel electrode with saturated KCl solution. If you fill the one normal KCl solution, it is called normal calomel electrode. Its electrode potential is equal to 0.2816 electron volts. If you fill the 0.1 normal KCl solution, then the electrode potential becomes 0.3335 electron volts. It is called decicalomel electrode. But always maximum times oftenly used calomel electrode is saturated calomel electrode. Its electrode potential value is equal to 0.2422 electron volts. That means the calomel electrode potential value, X value we know. So connecting metal is Y. So always X plus Y is equal to EMF of the cell. So we already X value we know. Y value is equal to EMF minus 0.2422. Like that we can determine the Y value very comfortably. So here there is no change of Cl minus ion concentration during the process. No need pressure, no need maintain pressure, no need maintain the concentration of any solution. So it is a very comfortable to use in different conditions than this SHE. That's why calomel electrode is used over the SHE for different experimental uh, situations. And from the overall topic we can learn SHE and calomel both are example for the reference electrodes. We can determine any other electrode potential by using these reference electrodes. And standard electrode potential of SHE is taken as 0. Standard electrode potential of saturated calomel is taken as 0.2422 electron volts. And these are act either anode or cathode depending on the connecting method. If you add a anodic metal, these ready to act as a cathodes. If you add a cathodic metal, they are ready to act as a anodes. Okay, so this is the topic. So by that we can determine all metal electrode potentials. Okay, so thank you for watching, and next class I will come with electrochemical series and its applications. So thank you for watching. Bye for